Okay, let's do a few more definitions, then we'll stop here, okay? Then we'll move on to examples, and we'll call it a day. So we're going to say vectors are collinear. If they lie on a straight line. When arranged tail to tail. To put that into English, collinear means they lie on a straight line, which means parallel. That's what it means. Okay. They are linear dependent.
Tip to tail,
Tail to tail.
tail to
Tail to tail, we'll just say. If they're arranged tail to tail, they're all on the same line. It doesn't matter. Because if they're arranged, if they go tip to tail, both of them, then they can be the same line.
Okay.
So they don't necessarily have to be the same line. That's what we're saying there. Then we're going to say they are called linearly dependent. That's easy for me to say. If they can be combined to form the zero vector. And we're going to talk about linear combinations of vectors here in order to get them adding to the zero vector. Okay, so we'll do a lot of things. We'll take two vectors and try and add a third and then make it equal 0 and go from there. All right, I'm going to do two examples here. Do you guys want more trig, or are you guys okay with if I skip the trig example? Is that okay? Because I mean, we've done a lot of trigs today. Let's skip the trig example. I'll do the algebra examples. Okay. So I have to skip one of them, so the trig example's fine. Okay, so here we go. Example 1 says, and I quote, we're good? Okay, example 1 says, I'm going to draw parallelogram again, which I love. That right there is going to be vector A. All right. This right here is going to be vector B.
Is that a parallelogram?
Yes. This right here is going to be vector C. And this right here is going to be vector D. We have other ways you guys can write here. Okay, so everyone see what I'm trying to do there? Okay? James, we're good? Yeah.
It's the square.
Parallelogram is supposed to be. Okay, so part A is going to say write vector A as a linear combination of vector B and C. So what I'm saying here is I want you to write vector A as a combination of vectors B and C. So this is similar to what we did last night, but I want to make sure that everyone's feeling good about this for how we're doing it here. So I want to get to vector A. How can I combine B and C in order to get A, please? What do I want to add? Yeah, go ahead.
B plus C plus C is
Okay, so B plus C is A. Not quite. Not close though. Negative, we'll say negative B, because we're going back in the direction, right? So if you go, because you're going to go here and here and then add B and go over this way. So we're going to say this is equal to 2C minus B. Okay? Because 2C gets you all the way along the diagonal and go from there. Part B is going to say, sorry, Chris. A is a linear combination of C and D. And C is going to say B is a linear combination of A, C, and D. All right, let's start with B first. Someone other than Austin, A is a linear combination of C and D. How would we add C and D together in order to get A? Go ahead, Cal.
C plus or minus D.
C minus D, very good. Okay, because again, if you're doing C plus D, you want to get down here. D in the opposite direction, moving up here. So this is going to be A is C minus D. Now this last one's a little bit tricky. So I said I want to write B as a combination of A and C and D. B is that one I got to add a combination of C and D, A and C and D. Okay, can somebody be brave and venture? And I might have to say I'm sorry, incorrect, but try and be brave for this one. Okay. B is a combination of A and C and D. Well, what's the easiest solution for B? C plus D. But if I have to include A in there,
Okay,
I'm
because plus A minus A.
B plus A minus A, you could definitely, okay? I'm just going to write it as 0, A, which is the same thing, okay? So I'm just going to write this as, and this is Mr. Saville being mean, okay? You could do like Bailey said, which is correct. Or whoever's getting text, can you turn the phone off, please? Or turn it down. Right, and again, simplified out, A minus A is just nothing, right? So 0A. Okay, we got the idea here, moving around that.
Which one would you add?
I'd probably rather the first one. It's probably better. Okay, one more example. Oh, we were flying now. I'm going too quickly there. Okay, ready? Simple 2. Here's some algebra. For vectors U and V, write 3U minus 4V as a linear combination of U plus V and U minus V. Okay, I'm going to slow down and try and do this one at a nice moderate speed here, because this is sort of getting away. This is a type of question that people will get on their test, and they will freak out about. Okay, please do not shut down, okay? We'll try and talk about how we're going to do this. So what I'm saying for this one is, I have to add together a certain number of U plus V's and a certain number of U minus V's together to get 3U minus 4V. Now, the nice thing is it doesn't matter what U and V are in this case. They can be anything non-zero. How would I represent a certain number of U plus V's? What would I call that? Let's go back to grade 9. What's an unknown number? What can we call an unknown number? A variable, good. So I'm going to say K of U plus V. Right, we're gonna add together K of U plus V. We'll pick another variable, then we're gonna say plus another unknown. Okay, so see what we're doing here, we're adding together a certain number of U plus V's, and a certain number of U minus V's to get 3U minus 4V.
Should the second set of brackets have U minus?
Yes, it's yours. Thank you. I'm getting too excited here, sorry. Okay, now if you're fading out of today's class, shame on you. And secondly, now's the time to fade in, okay? Because you're probably going to see something like this in your future, okay? And I want you to get the method of how to do this properly. Let's use some algebra distribution. How's your foiling feeling? Luke, can you multiply K times U plus V? What do you get, please?
Isn't it just K U
Plus?
K V?
Very good. And again, this is our okay, now the magic is going to happen, okay? Now there's way too much going on here as far as unknowns. I don't know what U is, I don't know what K is, I don't know what L is. So what I'm going to do is I'm going to change this into a nice set of equations that I can deal with. I'm going to make one, I'm going to separate them into so that I have just my U's together. Okay. Whoops, I should say LU, sorry. Why am I allowed to do that?
Because they have a common factor.
Yeah, like they're basically all related to U, right? Okay. So can somebody else write the other statement for me then, please? For the V's. Luke, go ahead.
So KV minus LV equals negative.
Very good. KV, whoops, I'm all over the place, sorry. Now I'm going to cheat one more time. So if you're into cheating, listen up. I'm not cheating. Okay? Since they're all, we're just going to deal with the scalars right now, which means I'm going to get rid of the vectors. So I'm going to say that since I know vector U is constant along the whole thing, I can write this as two equations and two unknowns. My first equation is K plus L equals 3. So you see how I did that there? Because they're still the vectors altogether. Can someone else please give me the second equation then, please? Luke, go for it.
K minus L equals K.
Very good. Okay, so you see what we're doing here, right? We're just dealing with that. All right, now I have two equations, two unknowns. Looking back at the test, how do I solve two equations, two unknowns? Go ahead.
Do you like combine them so can you like just do K equals K?
You can do K equals K. Yes. I'm going to do it a little differently if that's okay. I'm just going to isolate K on the left-hand side and then sub it in. So K here is going to be 3 minus L. But you're exactly right that you could do K equals K. But now I'm just going to sub this in over here. Okay. So I'm going to call this then 3 minus L minus L equals negative 4. So you see what we're doing here? Just substitution at this point. So this turns into 3 minus 2L equals negative 4. Negative 2L equals negative 7. L equals 7 over 2. Now I didn't actually mention this in the lesson before, but does it make sense that you can multiply a vector by a fraction? I'm going to say it can. I'm going to say that if I give 100% effort, that's 100. If I give 110% effort, I can multiply my effort by 1.1. For a vector, it's okay to do that. Okay, the same way for the magnitude. Like that isn't something that's weird. So I have an answer here of 7 over 2. That shouldn't cause you to freak out. Okay? How do I get my K now? Go ahead,
Sub back.
Sub back in.
L and
Yeah, I'm going to actually sub into this one because it's nicely already set up for me. So I'm gonna sub this back into here. So I'm gonna say k equals 3 minus 7 over 2. K equals -1/2. And we're gonna say then, therefore, -1/2 u plus v plus 7 over 2 u minus v equals 3u minus 4v. That's all we did. That's just algebra. That's all we did here. All right. Now, as far as tonight's homework goes, there will be questions that involve trade. We didn't do any trading today's lesson because I did so many homework take-ups. Okay. So I'm going to stop now, Bill. You look at your watch. We're going to stop now. Okay. Is that right?
Yeah.
Okay. So I'm going to break trunk on the board. There will be some trig stuff going on here. Okay. So I want to make sure your trig is like fast, like the cosine law and all that stuff, and finding interior angles and all that stuff. It's got to be efficient, if you don't mind me saying. Okay. Homework comes 334. Very awesome. This is for you. Okay, now this will involve a little bit of thought, those 20 ones in the 20s. Okay, that will involve a little bit of thought. You guys can do that at conference yourselves. I'm going to take that phone from you tomorrow, I swear. Do not bring that phone. You're bugging me today. Sorry, I don't think I yelled at you. Okay, good, somewhat good.